My name is Eric LeVine. I'm a group program manager for post-reorg, the Office Quality and Satisfaction team, formerly the Office Fundamentals team. You've seen a lot of different examples of productivity within Office. What my team actually has been focused on for the last couple of years is not creating new things, but just taking what's there and making it work. Super simple stuff, but just trying to focus on problems that are very, very core to the whole suite. When we sort of started out 2 years ago, the goal was really simple. Steven Sinofsky came along and said, hey, I want you to build crashless Office. Crashes, these things have been happening forever. Just make it go away. And in fact, if you sort of look around, there's a lot of data out there, some of it sort of in our faces, some of it that we hadn't really noticed for a long time. But if you start looking for it, it's all there. And what it basically says is that press, customers look at this entire platform that we've built and consider it to be basically unstable. It's a lot of, it's very easy to poke holes in it. There's a lot of different software and configuration, and stuff just crashes. It fails all the time. So one example of someone doing this very publicly was Walt Mossberg. Did a very simple exercise coming up on a couple of years ago. Just for a week, he kept a little diary. Every time he crashed, he would just write it down, or some weird error message, or some strange thing, and just wrote it down. And after a week, he came back and he looked at the diary and he counted up 27 different severe errors. And he got pissed, and what Walt gets to do is write an article about it that 30 million people read, so he did that. But what was a little bit different about this than any other article that he's written is he got about 10 times as much response back from his readers saying, yeah, me too. He sort of hit this raw nerve, and for I think 2 more weeks he just reprinted people venting about this, this core problem. So that kind of sucked, but so be it. It's fair. It's there. Anyway, if you look around inside Microsoft and sort of what we have available, PSS has a special name for any kind of a call that they categorize involving crashes, hangs, or data loss. They call those fatal events. I don't know if that makes it sound better or worse, but that's what they call them. And the numbers around those are actually surprisingly large. The company-wide satisfaction surveys, one of the top issues related to products is people complaining about crashes and blue screens, and it's fairly predictable, but they're right there at the top of the list. And of course, crashes, you can't really compare someone struggling with mail merge or pivot tables to someone crashing, because if they're just having a hard time figuring out the software, they may put the onus on themselves. But when they crash and they lose data, they lose trust in us and everything we built. So it could be one bad crash in Publisher, and for that person, for the next 6 months, Microsoft sucks, and that's that. And all the good productivity work we do just kind of goes out the window once people start losing trust. The problem with all this is, you can't do a thing with this other than sort of sense the frustration to actually make the products better. So let me, couple little caveats. Most of what I'm going to show you, actually, I've sort of spent the last couple of years, they don't really let me out too much, so I've spent the last couple of years going and pounding on different teams within the company from a development perspective about, hey, how do we change this? How do we start to make traction? So I tried to kind of take a different spin on this to say what's going to be relevant in this for you. The main thing that I hope you take out of this, by the way, is just understanding that, in fact, we're just at the beginning of something here. And as customers start to encounter this and see what's going on, that they don't freak out, that you explain it for what it is, and it's all about us just trying to have hooks in the product so they can share feedback with us about how it is and isn't working. We're starting with crashes right now because they're actually very black and white, very easy. But this is really the beginning of a software as a service type of thing. It was .NET before there was .NET from the maintenance perspective. Anyway, the basic problem is, for any given crash, there's probably like 3 or 4 developers on the entire planet where I have to get them in front of the source code that they wrote that's failing, and they may spend a day or 2 or a week tracking it down. So it's one of these really nasty problems where until you can get the right data to the right person, you're not going to make any headway. And you have to do it at the bug-by-bug level tens of thousands of times over and over and over again before you really start to make progress, or so we thought. This is a look at some of the fatal event numbers here. This is contrasting basically the amount of time from an end-user support perspective PSS spent talking to end users about Office 97 applications versus 2000 applications, specifically around tasks, fatal events, crashes, hangs, and data loss. I actually worked on Word for about 7 years. Word 97 was a fairly terrifying, very old school project. We partied away, whole big pile of features, and at the end we said, oh my God, we got to ship this thing. and made some brutal decisions, and boom, out it goes. And it wasn't a lot of fun. It actually did very well in the marketplace and held up pretty well, but it was a very sort of old school kind of approach. In Office 2000, we were actually remarkably conservative, doing enormous betas, trying to draw things out, looking for quality through all the traditional ways. And you'd think, hey, they'll make some progress, right? Well, if you look at Word, 15% of the time that we talked to end users in Word 97, we talked about crashes, hangs, and data loss. And 15% of the time we talked to end users about Word 2000, we talk about crashes, hangs, and data loss. So we made absolutely no progress. There are some local variations. Actually, Excel, for whatever reason, made huge progress between 97 and 2000, and PowerPoint went backwards. But everyone, really across the board, across the entire suite, is just dead flat. The other funny thing is, think about how many times you've ever crashed our software or anyone else's software, and how many times have you called up a support person and had, on average, a 30 to 35-minute phone call about it. It's got to actually be the total exception that someone goes to the point of calling about a crash. So we sort of knew, like, this was the number that for me said, I know what I'm going to do for the next who knows how many years, but this is a problem. Installation fatal events end up being a big problem as well, and in fact some of the techniques we're taking apply to that as well. It's just, there's a problem, now what the heck do we do? So, well, what we do is try to build something and go beat people back in Redmond over the head with it. So this is what I've been telling people for a long time, and this is what I've been hearing back. We don't have crashing bugs. Oh, it's a driver problem. It's clearly not our problem. And it's sort of, what we're trying to do is sort of engineer this big wake up to say, look, it is our problem. The most important thing we can do is to gather actionable data about it and just start fixing it, start making headway, take our heads out of the sand. There's people 2 years ago who literally said these things to me who, fortunately are doing their jobs differently. Anyway, so, if your goal is crashless Office, where do you begin? It's actually a pretty huge problem. And we didn't really know 2 years ago how far we were going to get in V1 of this. But we did know it's really important to think about this in two different ways. Robustness, I read some Gartner Group study that made a big difference between robustness and reliability. But basically the difference is, hey, robustness code assumes I'm going to ship with crashes. The basic problem we've always had is we kind of know we have crashes, but we sort of figure, well, we'll fix them all before we ship. Well, it never really works out that way. So let's put some code in the box, airbags, so that if something bad happens, there's code there to make that way less painful for the user, to take productivity back. And the best example of this is if you're using Office XP, which I hope you all are, in Word, Excel, and PowerPoint, you have the ability to save data after a crash, hopefully every last keystroke. And we've done a bunch of other different things in that space. But the net of it is, this is the beginning of us saying, hey, we need airbags. We need to take what people know of as a crash today and just redefine it. Now, the problem with all of this kind of investment is if you write code that's going to run when something's crashed, depending how bad it's crashed and what it's done to the system, who knows, right? This is ultimately, just a big Band-Aid. It turns out it's a Band-Aid that works a lot better than we expected, but nonetheless, it is just a Band-Aid. And so what you need to figure out is, well, why the heck is it crashing in the first place? And that's what this is all about. This is a longer term thing, and we felt it was critical we did some of this so there was something for the user right off the bat. But this is really what I'm going to spend pretty much the rest of the session talking about, which is, hey, how do we stop bad things from happening? We kind of knew, I mean, the basic thing we do is we party away, we make a bunch of features, work on it for 2 years, do a lot of big betas. Frankly, we do this better than anyone else in terms of quality, compared to any of our competitors, compared to what anyone else has done in the industry. I beat us up a lot, but we're doing it better than anyone today. And yet, still the problem exists. So we knew, like, hey, we're so conscientious about these things before we ship, and then we ship, we throw each other in the fountain and trash the atrium of Building 17, and we move on to the next one and just sort of forget about it all. Like, it's gone. That's someone else's problem now. But in fact, that's the first time it starts to get really, really interesting. So the whole idea was, hey, this is .NET here. Let's just pretend, let's count on a net tap being there, and maybe, we'll just give someone a really easy way to get some data to us, and we can do something good with that. That was the whole basic idea. So we wanted to get data from the wild, from 200 million people out there after we shipped it. And then the other idea was kind of this, is this very sneaky grassroots thing. We built this whole thing as a big pointy stick for our sustaining engineering team. So this is what they would use. We want to get out of the business of, well, we want to get everybody, the corporations, et cetera, who are asking for QFEs in the business of focusing on the issues that are really impacting their users, that are causing the biggest problems. many of the QFEs we fix today, I don't know if I would actually classify them that way. But the idea is, hey, let's everyone focus on the right set of issues and focus on them together. So we wanted to build something that was going to work pre and post ship and was all about pumping data right back at the product team, because that's the source of the problem, right? If software is crashing, you can call support and try to work your way through there, but the support engineer isn't going to check in the code that's ultimately going to fix that. If there's a workaround that they know about, hey, they can get that out there, and that's cool, but we can automate that too. And then I'll get into, of course, what this means for corporations. We started just really simple, going, well, whatever. We've got to build this simple, focused thing, and we'll make it work for end users, and then we'll worry about a bunch of other stuff. So I'll get into that. An interesting thing that happened along the way was we were all along just thinking about Office, and then we kind of got about a year in, and this is one of the first times we've built something from an Office perspective that's designed to be a server-based service that's going to scale to hundreds of millions of people. And we started getting pretty scared, so we were like, hey, we need someone else to test this out before Office ships, because we get 50 million people deploying Office in the first year or buying it, whatever it might be, and it would be awful if all these servers we set up just kind of came tumbling down. So, hey, along came the Mars team, MSN Explorer, and they said, hey, we want to be a guinea pig, and we said, great, perfect. So the funny thing about this service I'm talking about is already today, actually, every beta of MSN Explorer, and since October for IE, you've been able to go up to Windows Update and pull down Internet Explorer error reporting. It's all the same feature. It's all the same service. And there's actually already 10 million of our customers out there pumping data up every day, lots and lots of data. And in fact, in a whole next generation of products, whether it's VisualStudio.net or actually in Whistler, this is done at the OS level. So we're actually getting Office 2000 data right now on Whistler. This is basically totally generic, a totally generic approach to tracking errors. Very focused on crashes right now. Okay, let's get into the meat of it. These are always funny. This is what we show customers today. The funny thing is, if you sit down with a support engineer, when customers call, I mean, this is great. When you can use instruction and reference and terminate all in the same dialogue, you've done it. This is the pinnacle of end user design. But in fact, about half the end users that call support actually think they did something wrong. They see a legal operation or something like this, and they assume that they did something wrong. And I mean, for us, that's not really a problem, but it's out there. And so this both isn't really helpful and is particularly unfriendly. So we tried to come up with something that was both a little bit more humble, a little bit more understandable, but had a big punchline, which was ultimately, hey, click this button, send error report, pump data up to us. So I'll get over and show some live code in a second. But really, the main thing, by the way, this is going to start to get very repetitive here in a second. It turns out the way we do all this, at its root, has a we have a simple approach to how we gather and track this data. I assume everyone who's using Office has probably seen that dialogue at least once. You probably wonder, well, where the heck did that go? I know Steven Sinofsky talked about this a little bit, so I'm going to try not to dwell too much on the specific things he showed you. But the net of it is we have a way of grouping this information that ultimately, when it gets back to Redmond, lets us do fairly amazing things with it. So we leave a little breadcrumb trail on the client about what happened. And in fact, so this grouping, the magic in all this is what we call bucketing. And again, we were pretty simple guys, and we just said, hey, we know there's going to be a lot of data out there. We don't want to pay for servers, to gather huge amounts of information every time someone crashes and reports it. And what we don't want to do is build some big black hole in the sky that just starts sucking up data, and we have to fill terabytes of it. And it's like a permanent employment act, because how do we automate getting in there and finding out which are the worst issues so we can actually make some headway? So that's what we were terrified of, and we came up with this approach, which was, well, let's group the stuff around name of the app that crashed, and the rest of the presentation, everything I show you, I'm going to keep coming back to these 5 things, these bucketing parameters. Name of the app, the version you crashed in, what module you crashed in and its version, and then the offset is literally how far were you, what instruction were you at in that module. And right then and there, on that client system with no debuggers, no symbols, nothing magic, just out of the box, that alone is enough to help us start to group this information in a very, very interesting way. And what that lets us start to do is hit count for each of these and start drawing pretty curves that let us make a lot of impact. Gather data, gather custom data. We actually have interesting ways for particular errors to be able to get lots more data if need be, and ultimately ways for corporations to exercise that as well. And what it all comes down to is when it's all said and done, this is all about driving fixes, both into the product and then getting them back out to people. So you want a way to respond to people who are hitting these errors and going, hey, I'm sorry, but hey, I fixed it. Here it is. And hopefully you'll never hit it again. And then from a client-server scale perspective, ultimately, we don't need 100 million crash dumps for the same particular crash. We need something tiny, like 10, and the ability to go get more if need be. So that's kind of at the root of all of this stuff. The only reason I dwell on this, I'm actually going to skip a lot of details about how this is all built, but when you end up encountering customers who are hitting issues, this bucketing thing is at the root of everything we do in terms of what we log on the client, in terms of how the corporate error reporting works, and how we interact with the information back up here at Redmond. And it turns out, magically, like if any of you are crashing today, if I can get these 5 parameters from you, back at Microsoft inside the firewall, I can literally see what issue you were hitting and what the latest state of that is. And that's a very powerful thing. So this is, I just ripped off a couple of Steven's slides. This is a real live example of a crash that Steven hit. This is what was in his event log. And this is something that basically developers and testers are using right now, thousands of times over. And so here's the bucket. In this case, this was PowerPoint 2526, crashing in PowerPoint at this specific offset. We've got a bug number. We've got a call stack. Actually, I know this one. This was in the RC, but it's fixed. It's you paste a table, undo, paste an HTML table, undo, crash. Oops. Well, we got it. And here it is. We just literally fixed it the other day. The interesting thing is we've been doing this, actually, through Beta 1, through Beta 2, with the RC build, with every live build along the way, and just scooping the cream off the top end of this. We're, again, really simple guys. All we wanted to do was fixing any failure after the fact. And it turns out we're really good, by the way. I think our existing methodology is great at, I do X, Y, Z and crash. We tend to track those down and get, huge percentage of those before we ship. But what we're not good at today is I use Outlook for 2.5 days and I boot and quit and blah, 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 millions of things, and then it's crashed. And today, that just completely defeats us. And, if we happen to get lucky and catch that before we ship, great. But, there are some of those that just we don't get today. And yet, with a tool like this, you see them. You see ultimately what code is failing. So this is actually the curve, the actual curve from a day old on the 2511 RC build. And there were 2 issues that were just atrocious, and we've nailed those. And in fact, the top 40 issues, the whole point of this is to draw these issues in such a way. I mean, we will still ship with crashes. I promise you, we will not fix them all. But what we want to do is focus people on the right ones and make the code quite a bit more stable. So what you see here is the top 40 issues out of everything we've seen are half of the curve, and that's across all of Office. Now, actually, the amazing thing is, so far out of this, we've actually picked off about 110 of these. So we're getting deep down into here. And that's just in the last 3 weeks. And we did that at Beta 1. We did that at Beta 2. We're just scooping the cream out of this, and we're just going to keep doing that, in fact, once we ship. That's what our sustained engineering team is going to do. And in fact, that's what ultimately everybody at Microsoft has to do for every piece of code we ever ship, is get ready to deal with this and have an army of people where, well, especially before you ship, it's great, but even after you ship, you can't forget about it. And that's where MOSE, Microsoft Office Sustaining Engineering, comes in. We've basically built them a great big pointy stick, and they're going to use this for the next 2 years to keep attacking the fat end of the curve. And maybe someday it flattens out, but hey, this is V1 of this. This is really just the beginning. Okay, and ultimately this is what one sees as a response. I'm going to just show this to you live from the corporate perspective. From the corporate perspective, now I know you all, so here we are in PowerPoint, and I'm going to go ahead and print, and oops, that didn't work out too well. Okay, well, actually, it's a demo, so I'm the only demo that, I really want to crash, and I get disappointed when it doesn't crash, but it's so funny, because, all the way along while we're demoing to executives for the last 2 years, someone else would crash, and I'd be like, woohoo, yeah, they would, they didn't look at it very kindly. So here we go, PowerPoint crashed. Drilling in a little bit, here are those magic 5 things right there. Anyway, the net of it is all I have to do is click, send error report, and then bang. That one was awfully quick. It turns out we don't actually gather huge amounts of information. We know which specific one that you hit based on those 5 parameters. We don't need 10 million crash dumps. So in this case, whatever I was hitting on the back end actually knew that it had all it needed. So I'm going to close this. And it's come along and said, hey, guess what? Well, actually, it's done a couple things. For starters, it saved all my information, so that was cool. That's the airbag side. But it also came back and said, hey, there's more information available. And the way it did that here was actually in this case, we have set this system up on the client side, and this is what ultimately I think a lot of we sort of were confronted with this basic problem, which was we built this cool thing that makes perfect sense for an end user, and yet we knew the first question any corporation was going to ask was, hey, can I turn it off? Which, yeah, of course you can, but what an absolute loss. So what we wanted to do was give them a way to play in this game together with us, but in a way that addressed their concerns around scale and security and privacy. And so what we built is really a what's the right way to say it? A very simple solution. There's not actually a heck of a lot of engineering going on here, but just something lightweight that wouldn't take a lot of administration, where they get one policy key onto the client system and redirects basically people to dump crashes on an internal corporate server. I'll click around in here a little bit and show you that, but the net of it is, so this was the particular crash that I just hit, PowerPoint, this particular one. And what we let you do in this case is ultimately the idea is they set up their users so that they can pump data to a corporate repository. They can use this tool to go ahead and view that data. And ultimately what we want them to do is go ahead and literally report either specific buckets or the whole mess back up to Microsoft. And up at Microsoft, we're of course actively hacking away at this data, trying to figure out what's going on. And when we figure it out, we put a little URL in the database and send that back down both to an end user where they would see that more information dialog, or in this case to a corporate admin who's going to see it here. And what the admin can ultimately do is choose to, of course, every aspect of this. You can dial the volume controls and say, no, never ever let an external URL trickle through to my end user. But of course, I want to see it. And you can allow or disallow many different forms of the sort of extensible data collection. But ultimately, they can go ahead and, in this case, redirect to some local patch, some local page. It just lets them sort of co-opt the mechanism in a fairly simple way, without having to set up a lot of heavy-duty server stuff. Literally, you just kind of point everyone at a file server, and we're going to start dumping some data there. And then there's this admin tool that's part of the Office Resource Kit that you use to go ahead and maintain that. So fairly simple stuff, really. So, in fact, yeah, the next set of slides talk about that. I'm going to click through this pretty quickly. We actually worked with the various Office Advisory Council folks. Actually, Mike Jordan was one of them at the time, but now he's amongst us, so that's cool. But basically, just trying to figure out, again, how we solve this basic problem. Let's see. So basically, it amounts to file server space. We have actually a lot of policy in general that operates, independently of this corporate thing. Basically, all you set to get the whole corporate thing in motion is DW file tree root. You get that one policy key onto the client system, and that little client crash dialog forevermore is going to start pumping data there. And then all the rest of these things are things you can specify on the client system, or you actually have the ability via that Corp Watson tool to set them for particular buckets. You can actually set them for the entire file tree. You can really control every aspect of what data we're allowed to collect. And there may be cases where they're hitting a bucket and they'll see when they synchronize it that we as Microsoft are asking for more information, like, oh, we would love user documents, which we have the ability to gather, although that's non-default. And they may just say, well, we never, ever want that to happen for our users. Of course, they can do that themselves for their own users. So all these policy keys sort of let you control that, and this is all just part of the Office Resource Kit. And it all just kind of lays down, actually, it's just easier to about it and not to just show it. I'm very used to talking about it and not just showing it here. So the whole shooting match here is literally that the clients in this case are just populating 3 different directories. At the root of this is an optional feature. Actually, when the data comes to Microsoft, it's completely anonymous. We actually have no idea who the users were, anything. But within the corporate firewall, the tools we give actually let them see what was the, when, where, who was it, etc. So from a corporate help desk perspective, this is a nice simple thing. You can sort of control, actually tracking equals yes is the thing that turned that on. You can sort of control the whole shooting match as an admin from right here. And then within each of, actually easier just to use this, what you can see, those same 5 little pieces of data, app version, module version, offset, this is how we're gathering the information. And the client automatically populates this. And then down here, these cab files contain the actual crash dumps. And so the whole system, where the version we use that we're hosting ourselves on our own servers, of course, has IIS and SQL and a lot of machinery behind it. But this is just hey, point me at some hard drive space and I'll start filling it up in a fairly conservative way. And that's the beginning of the whole scenario. So the next set of slides just talk about literally what that looks like. And from a corporate perspective, the trickiest thing, frankly, is just to set it up so that where the cabs land, ideally, you would probably set up write-only, so anyone can dump data up there within the corporate firewall, but no one can see each other's data, of course. You don't really, very often, you wouldn't want that. You're going to have a tree that ultimately where there's like a little hits.log thing where that's going to be read-write. That's just sort of the internal corporate, how many times has it been hit? Because after n number, it's going to stop gathering. And they can dial that to, oh, I want 100 cabs. They can say, I want no cabs. I think by default it's 5 cabs. It's just to minimize their storage requirements. And then ultimately there's a read-only one where they can, that selected bucket policy, of course you want people to be able to read the policies for a particular bucket, but you don't want clients in the enterprise environment to be able to modify them, because if you as the corporate admin say, you're subject to X policy, then so be it. That's the whole shooting match, really. And then the Corp Watson client, which is what I was demoing in, was the tool that lets you more easily set the policy and edit it. It's a I'd be lying if I said these were particularly elegant or fancy tools. It was just like we saw the scenario there and we said it's important we address this. And so this is the beginning of something. But it was designed to be super duper simple for the admin to just get these basic things going here. Now, the admins, of course, the corporations can choose to, we would never ever want them to turn it off. And in fact, the important thing is out of the box, if people can browse just using IE, then out of the box with Office, they're going to have send error report, and that's going to go straight up to our servers, because that's all we're doing is just standard HTTP operations. So a corporation is going to have to take a proactive step to either just turn that off or block people at the firewall level. Ideally, as soon as they start getting nervous about this, that's the whole point of this, is you say, no, this is a good thing, but you steer them towards this corporate approach. And they're going to be nervous about privacy and security and a bunch of things that we've thought a lot about and think we've addressed, but still, control is the key thing here. And then this tool is, basically lets them start to manage that process and deal with this locally. And there we go. So, any questions on that? I'm talking a lot. Yeah. Okay, so yeah. So the question was, once the information is filtered through, how does it get back to us? That is in this tool here. Literally, what the admin can do, and they can automate it, is either report selection takes a particular bucket, or report is going to start the process of taking this repository and just talking to our server repetitively for each individual cab file. It's going to start pumping it up and talking to our server, which may or may not want data. And this is all command line drivable, etc. So the idea really would be to get, that an admin is going to do that on a regular basis. We really want people to just trust it enough that they just set up a batch file that just does it every night and they call it a day. But we know that people are going to have varying degrees of trust, so we sort of want to cater to that. Yep. Right. So the question was, how does ultimately the feedback loop close with the user? So the idea would be that, in this case, back in the tool, what you can see is Microsoft response here. That literally means that for these particular buckets up on the server, someone said the URL to send back was, www.microsoft.com Office. In this case, what they've chosen to do via policy, and again, this is not the most elegant tool in the world, but is overridden that for that particular bucket. So the idea would be, the admin can choose to set this all up and synchronize, and they can have just one policy key that says block external URLs. They'll see them come down. They'll be in the read-only portion of the policy tree, but they've set policy in the tree that says don't let that percolate to my users. By default, that's not going to be the case, so it percolates through. But they can flip one switch and then bingo, it doesn't percolate through. But then, if they're going to repackage patches or do things locally, write local workarounds, whatever it might be, then synchronizing that and seeing those URLs come down starts the feedback loop. Question back there. Yeah. Question was, how can you fake the crash? I am running some fault injection tools that actually, it turns out when you work on things that are all about saving data after crashes and reporting crashes, you need a really good, predictable way to make the software crash. So we have some fault injection tools that we have the ability. We don't really like to give them to customers, but they're part of the demo setup, et cetera. Yeah, it is part of the demo thing. Yeah. Question up here.
The resource kit, is that included in the RC1?
The Office Resource Kit is, yeah, it's a part of all the enterprise SKUs that is in the RC1. And this is one of the tools in there. Question back there? One more time, the question was, are we doing this for the operating system? And yeah. Yeah. Right. Okay, so the question was, hey, what about, so we're looking at application version, what about operating system, et cetera. So there is one other related effort in the company called OCA, or Online Crash Analysis. That's all about blue screens, or what are called kernel mode faults, and that's all about hardware and drivers. In Whistler, actually, when you reboot after a blue screen, it's going to offer to send that information up using the same little client app that goes to a different backend, and there's a different team working on that backend aspect of it. The actual techniques here ultimately are extensible to any error. In the first iteration of this, it's all about crashes, and so this is all about user mode or application crashes. There is, again, a separate effort going on in Whistler around blue screens, although I can't talk too much about that. Another question back there. So the question is there any thought of licensing this, et cetera? Yes, but there's not a lot I can say about that right now. The actual technology here is pretty brain-dead simple. And how we choose to extend that out as a platform service and as an ISV service, and thinking about this in relation to the URT, et cetera, it doesn't take too much to look at this and kind of see that and start licking your chops. So, we're working with literally every part of the company to try to drive this as a great big wave. But today, it's not there yet, so don't do any promises or anything. I can take a couple more and then I can keep going. But okay.
What happens to the traditional Dr. Watson service? Does it go away? Is it still running in the background?
The question is, what happens to the traditional Dr. Watson service? Does that go away? Is it running in the background? In Whistler, it is actually there in the background. It doesn't handle Office faults because we, in essence, handle our own faults. In general, the way that this stuff all interacts with any debugger is if someone has an auto-launch debugger up on the system, that's going to take precedence. Or if they have a debugger installed that's not Dr. Watson 32, they're going to have a debug button in our crash dialog. That's the main story there. I'll take one more question and keep rolling. Yeah.
When you report the bug, if we have one answer, how do you then feed back to the customer when you do things?
So the question is, hey, someone reports the bug. Let's say we don't have an answer at that time. How do we get back to them? So today, this is very much an anonymous sort of throw it over the wall thing. And at the time someone reports, if we know about it, then and there we'll tell them, hey, there's more information. How we start to close the loop and manage expectations around all this. What we really want to do with all this stuff today is start off with expectations very, very low. Because I promise you, even though we're making enormous headway and hammering away at the fat end of the curve, we will not fix all of these. This is going to take generations to weave our way through. So we really do want to get to the point where we can more aggressively close the loop, or especially, say, with a premier set of customers, do that. I mean, you sort of see this. It's so tempting. We're really, really early, so we're trying to keep expectations rather low right now. That said, there's information. It's a very good segue, so I'm gonna take it, and I will answer more questions later, to some of the support interaction scenarios. Because, of course, I mean, you sort of see this, right? So I'll talk mostly from the end user perspective, but of course, this really applies all the way up for any escalation. We sort of can envision a few core scenarios here where you've either got, a support engineer getting a call either from an end user, or this is a premier escalation, and you've got the crash dialog up itself, or even a non-connected customer. The scenario we designed for, by the way, let me skip to number 4, was the connected user who doesn't even bother calling, right? They just go ahead, they send error report, we know something, bang, there we go. And we're deploying back a URL, which in essence is going to be a pointer off to the knowledge base, or maybe Office Update, or for any team in the company, wherever they host however they choose to distribute updates, etc. In between, so then there's the traditional escalation, and let's say it's a crash. What happens there? The next one down is, hey, we're going to be sitting here working away at this data. And I got to tell you, one of the key things about all this is these are not easy issues to track down. I mean, when you know I do X, Y, and Z in crash, that's something that we can sort of take in a lab environment, reproduce, understand. When we make a fix, we can verify that. What we're being confronted with today are, well, we don't really quite know what the user was doing. We sort of know what code was running, and we see what the error condition was that triggered the failure. And looking at the code, we pretty much believe this is what will fix it. And sometimes we can actually work back to, hey, the user did X, Y, and Z, and that caused the crash. But we don't always have that. So, you know, these stump us pretty badly. Now, we're getting more and more and more developers who are getting very creative about this. It's a wonderful riddle for them, and they love riddles. But the idea is we want them, if they're going to spend a lot of time on these, and they do, we want to have them spend it up on the fat end of the curve and not, you know, plink around for 2 days on something that, you know, 2 people have ever hit. So that said, escalations are going to happen while we're in the middle of being completely stumped. Corporations are going to be hitting these things. So there's this incredible opportunity, especially for our support organization, to think about how can we tie these people together? Because it may be that data we get from support about a particular incident that's at large and we haven't figured it out is the thing that unlocks the mystery. We've sort of seen this play out internally. Actually, there was a crash that someone sent mail to the, you know, the little dog food support alias about in the RC. It was driving him nuts, and so he sent mail. We said, hey, you know, give me your crash log off your system. He did, and we said, oh my God, it's this one that we're completely stumped on, and it's a disastrous bug, and we nailed it. And this was just, 2 weeks ago, and so this is playing out over and over and over again. And of course, it doesn't stop when we ship; it just keeps going. The last thing is our sustaining engineering team, of course, has to prioritize this whole new world with what they've always been doing, which is trying to deliver value and QFEs to corporate customers. And in essence, we're making more work for them, but I think we're going to these tools are clearly, we're not naive. We're going to be helping corporate customers kind of hold our feet over the fire and toast them. But I think what that's going to do is sort of focus everyone on the issues that are really actually affecting users. And so these are some of the scenarios, and it's like, oh wow, what do we do? And again, we're really simple guys. It always just comes back to those 5 silly pieces of data, which is what app, what version, what module version, and offset. That's the starting point. We don't actually usually need that person's particular crash dump for 99% of the time. We just need to know which particular bucket they're hitting, so to speak. And so in the crash dialog, that's there. We log that on the client system. The corporate error reporting tool is all about really capturing that along with dump files. And so this is all about basically, ultimately, and today this is fairly immature, but we are going to build out around this. The goal for V1 of this was very much around getting data and sort of driving it back into the product team. You start looking at what this means for support, and there's a lot of very obvious and very tempting scenarios there. So we're scurrying as fast as we can to try to flesh those out. But this started off as just really simple, straightforward type of thing. And so, but that's kind of what this all leads back to here, some of these scenarios. Let me talk for a brief moment about privacy, and then I think I'll have, I think I'm just about done with slides, and we can get back to questions. There's a couple of stories that I just don't want to be on the cover of the New York Times. Probably will be no matter, actually trying to be incredibly proactive about this, but we're sort of scared to death. One of the biggies is privacy. What we tried really, really hard to do with the folks who run our corporate privacy team, Richard Purcell and Greg Hampson, is to make sure that the user interface around this and the entire way we gather this data and the motivation behind it is all about informed consent on behalf of the user. People understand what they, might or might not upload. It's something they have to opt into, not opt out of. And the stated intent of all this is all about fixing problems, fixing bugs, crashes, call them what you want. And generally speaking, while the mechanism itself is fully intended to be anonymous, people ultimately are pumping ranges of memory up, from that their application was using at the time they crashed. We try to let them see what that means and explain that to them in end user terms. It's their choice if they don't want to do that. We may actually, while investigating some of these, find their name in there somewhere or their credit card number, heaven forbid. And so we have, in essence, as part of the privacy policy and literally in the user interface of this little application, we talk about the fact that, hey, whether or not we find customer-specific information, we aren't going to use that. We're only using data to try to track down what code is failing so we can fix it. So gathering sensitive information in and of itself is not a sin, but having a stated intent and guarding that intent and living around that is critical. So we've tried really, really, really hard to be as proactive as we can here. There's always the chance that when people first encounter this, they freak out, and so, I mean, it's always their choice not to report. But I know I'm beating this with like a dead horse, but it's a very interesting sort of sensitive topic. So something we've tried to be very attuned to. Okay, that's it for the slides. I'm sure there's probably plenty more questions, so I'll just keep going in the time ahead. So more questions. Have at. I'm sorry. I don't. Oh, there we go. Back.
Can you talk more about the origins of this idea?
The origins of this idea, I mean, this was Microsoft at its coolest, okay? This was one developer who's been at Microsoft 13 years, kind of a cranky guy. December of 98, we're just finishing up Office 2000. He sits down, he writes a memo and says, crashes suck. We should do something about it. John knows the developer, so he's laughing, but that was literally it. And, he got 2 other people to say, yeah, I want to do something about this. One was me and one was one other guy. And 3 people, we basically went and built the beginning of this. Nothing particularly fancy. The technology here is incredibly straightforward. We were Office guys, so we were terrified of how to build out the server. And boy, 2 years later, we know way more than we care to know about a lot of things. It's not like we're debugger folks. And, actually building the pipe to gather this data, the whole point of the pipe is just get the data up as quickly as possible, throw away as much data as we can, because we were sort of designing for the 100 million case and not for just a little beta program. Along the way, we just kind of started realizing this is actually very generic. This applies to all failures in all software, potentially, and it's just something we need to start evangelizing. And at its root, this is all about giving the product team tools to understand how the code we shipped is operating or not operating in the real world. All code fails. Client, server, embedded, everything fails. So what are we going to do about that proactively? And so, again, the actual technology here is fairly simple. We just keep going back to those 5 things. So there's not a huge story, but along the way we sort of found other teams and wanted to sort of have them as guinea pigs so we could have, say, 10 million users hitting our servers before we shipped to make sure they wouldn't fall over. If they do fall over, it's not like we need every last report. So, but they're staying up very nicely. And so that was it, really. Very, very simple, very straightforward. Question here.
After the error report is sent, the user gets a dialog box returned that says more information. If you follow that link, you may get a fix or not. Is there a reason why the link says more information instead of like check for fix or something like that?
Okay, so the question was, if the user is hitting a particular bucket where we've gone and said we know what this is and have put a URL in there, then they'll see a dialog that says more information. Why did we just say more information? We can actually use that URL mechanism in a number of ways. And we talked a lot about having that dialog try to be a little more attention-grabbing or more specific. The primary way we thought of course, was to pump down a URL to a patch or maybe a knowledge base article for a workaround. We're actually using this in other ways where we can actually use this, like if we're stumped, we can actually pump down a URL to a page to fill out a survey, tell us who you are about this particular one, and tell us what you were doing, so we can actually sort of use conventional means to go get back in touch with people. So to this whole mechanism and to the client app, it's just given a URL, and its job is to just put that up, and that's that. So it doesn't know too much about the intent of the URL. So it was really just simplicity. We would like to, I mean, again, this is very V1. We just tried to keep things super duper simple. We want to make that feedback loop in the future a lot cooler, a lot more automatic, a lot more compelling. So, here.
May not be something you can talk about, but have you had any discussion with or had any interest from third-party help desk providers on tying into this somewhat?
Question is about third-party help desk providers. Not yet. We know that the sheer existence of doing this, is going to start to raise awareness around that. We're certainly very interested in talking to any ISV. Well, we're certainly interested in learning and talking and understanding. We know that just doing this sort of begs the question on so many other supportability and help desk scenarios. We're certainly talking to everyone within the company who thinks about that. The Microsoft Operations Manager team. There's a lot of teams thinking about these kinds of things at the client level, at the server level. So, I mean, while we're simple guys, we're not dumb. We're sort of scurrying ahead. And what you see really, again, when I say this is the beginning, I do mean this is just the beginning. This is a simple manifestation of some fairly straightforward ideas, but that clearly have a lot of room to roll ahead. Yeah.
Continuing on that.
Yeah. Yeah, so again, the question was about, hey, if you're building applications yourselves using our tools, I mean, this cuts across anyone, whether it's a corporate developer building something in our tool set, or whether it's an ISV, or whether it's us ourselves. Today, this is pretty much us. I think in the future, there's a lot of different teams within the company we're talking to, but nothing public, nothing, there yet today. I think, again, the question's going to get asked, so we are very interested in those scenarios. As the Office team, I don't know if we're going to build those out for the whole company, but the VisualStudio.net team is incredibly interested in what we're doing. They're using it for their own purposes as an app, but it's again, a lot of this begs the question. So it's sort of very early 1.0-ish type stuff. Yeah.
Just to get this
Yeah.
So when I use the corporate reporting,
Yeah.
you get this file share up there, which all the components go in there, and every night or once a week I upload this to Microsoft. So this URL you had in the tool, is that something that came back after reporting? So I can go as an admin, go there and say, well, I have this override URL, so go to the local internet.
So the question was, hey, you set up this corporate error reporting share. It starts, your clients out there start pumping data up to it. You start seeing form. You use this corporate error reporting tool and pump it up. What will happen is for those particular buckets, those combinations of app version, module version, offset, if we as Microsoft say we know what this is or we've put any form of a URL up in our database, that will pop up in front of the admin. And at that point, that's the trigger to the admin where they can choose to override that. They can follow it, of course, themselves and figure out what's it pointing to. Is it a workaround? Is it a patch? Maybe it's both. And figure out how they're going to deploy that in their own environment.
But that's the way to distribute hotfixes as well. So my end user will hit this bucket and get the corporate internal web page, which I, as an admin, copy the hotfix.
Correct. Yeah, the corporate admin, in essence, can choose to use this to deliver hotfixes. This is all very sort of reactive. It's kind of a nervous system like, ouch, and then you can at least say, well, here's a Band-Aid. Ideally, the admins what you want to do is sort of see a pattern happening for a particular set of users that you may have started to deploy to, figure it out, go get something, and then, of course, deal with the core problem before you deploy more broadly. This is just, corporate error reporting is just a tool for corporations to monitor the stability of Office in their environment. And so they can sort of see their own microcosm of what's going on and what issues are getting hit and hit the most. It is interesting to note, by the way, that the official way that escalation works today, this is just a tool set out there, right? It's just like we've given people a kind of a lightweight debugger just out of the box. And none of the official policies, nothing there changes. I think as customers start to I think it's inevitable that there will be change driven by some of these things, and we, again, are very interested in those scenarios. But the simple what's there today is really rather simple, so that's what we have right now. Yeah. Question, actually, up here, sorry. Yeah.
Is the information that the user is sending across the wire, is that being encrypted, going like SSL or?
The question is the information the user sending encrypted? Yes, absolutely. There's I didn't delve into the way the network conversation works. There's 4 different parts of the conversation. 3 of the 4 are encrypted. 1 of them isn't for scale. And at that point, there's no sensitive information being sent. We worried quite a lot about things like DNS spoofing and people taking over servers between us and the user and pretending to be watson.microsoft.com. And that's, we believe we are fully protected against those scenarios. But I also know enough about security to know that, security is an ongoing foot race, but we've thought a lot about making sure that the users are safe in this scenario. Security and privacy are just at the base of all this.
Do you have any data about how many errors are currently being captured or reported through IE and Mars?
The question is, do we have data about how many errors are being reported about Mars and IE? Let's see, this gets to that other thing. There's privacy, and then there's software has bugs. These are going to be the two big questions this all raises. The Mars team and the IE team are working very aggressively with the data they're getting. I can say that the Mars team has been using the data really aggressively. I think they've delivered something like 13 QFE releases across their beta cycles, driven largely by what they're getting from this tool. Mars, by the way, I don't know how many folks have used MSN Explorer much, just a nice little consumer-oriented browser. They've done a particularly interesting thing, which is they have an automatic deployment mechanism. So when you log on to the service, if they've put new software out there, it will actually trickle down and update you. And so they have the ability to literally change the stability of their software in the field, just on the fly. And they're doing quite a bit of that behind the scenes. And IE is also, again, everyone who's, it's easy to gather data. Doing something with the data is something that, people have to chew on very hard and is actually a much harder problem. And so, this is changing the way that Office works, IE, Visual Studio. Every team that plugs this in has a responsibility to go up, and do something with that data. But talking specifics gets tough. It's kind of up to each team.
What exactly kind of information are we sending in these lockdown situations?
Okay, so the actual information we send let's see here. The actual information we send, let me go ahead and show you one thing here. The link won't come up, but at least give you an idea what's going on. The actual information we send is something that, so for any user, this is this dialog basically talks about the kind of information at a high level that we send and what we will and won't do with it. It's about, it's an end user description with intent. And it's a lot more text than we like to put in a dialogue, but this is the gist of it. And ultimately, if you click this link, you get to a stated data collection policy out on the web. We're not connected, so we won't get there. That goes into more detail. And the gist of what we gather is actually something just called a user mode mini dump. It's like a Dr. Watson log, but with a huge amount of information left out. It's meant to be very, very small, compressed very well. It is literally like an autopsy just grabbed off the client system, whose sole purpose is to be able to take back up to Redmond and drop into a debugger with basically symbol servers of all the symbols and code that we've ever shipped, and put the developer in front of the line of code that crashed. So it's basically called a user mode mini dump. If you go to the platform SDK, starting with the Millennium version of that, that's actually been documented. In Whistler itself, dbghelp.dll, there are entry points in there that any ISV can use to read and write mini dumps themselves. And so we actually worked with, in essence, the NT-based debugging team to drive the creation of this new compact crash tracking format, get it documented, and in essence supported for any ISV. And that's what we're using. And then debugging tools itself, like Visual Studio.net, out of the box supports debugging these mini dumps, as do Windbag and all of the other tools that we distribute as part of the platform. The information we actually, so the mini dump itself contains information about what, basically stacks. For a given app, basically it's information about what was on the stack for all the threads in that crashed app, is what we gather by default. I do not believe we get like Pentium processor ID or anything like that. We have the ability, there is an interesting aspect to this, which is we have the ability for specific crashes where we can actually ask for more information from the server. As developers, we can initiate requests. If we see someone crashing in the speller, we can put a request on that bucket. So all future people hitting that crash, we can ask to get their custom dictionary or something like that. And our client knows how to gather these other things. And that's a secured conversation. And actually, so another dialogue would come up smack dab in the middle. Very few people will probably ever see this, but we do this. And of course, it's, again, non-default. They can immediately go cancel, cancel, cancel. And that's the kind of thing that an admin can completely control. They can block that from ever coming up and saying, never, not my users. There's this basic presumption, like, for any one of these crashes that's happening in the real world, there's going to be a lot of users who aren't going to be willing to share information, but, some grandma in Omaha will share the information. And that's all it takes is one user to give us the data we need, and then bingo, the mystery's unlocked, and we move forward. Again, we can gather customer-specific information, and we make no bones about that. What we're very clear about is what the intent is around that data, how we use it, how we protect it. There's nothing wrong with gathering personally identifiable information, so long as your intent is stated incredibly clearly. We'll never, ever let the marketing people, for instance, anywhere near our database, because this isn't about anything other than fixing issues. That's that. And in fact, literally, we have safeguards in place around that. What's that? Why do we send the product ID? We have a few things in place that we gather. The product ID gives us information about whether this was a unique installation. We just like to have that in our back pocket just in case. It's actually not used, can't be used both, and will never be used to go and track a person down. but it's information that we choose to gather along with this. It's actually up to each application that integrates this whether they choose to send that. In the case of Office, we do. Again, gathering sensitive information is an okay thing so long as the user has informed consent, and it's their choice to be able to say no.
I'm
Yeah.
sure a reporter's going to ask us about this product ID and our anti-piracy campaign.
Yeah, the question is, what have reporters ask us about product IDs and anti-piracy? The data we gather can only be used for fixing problems and nothing else. It cannot be used in any way, shape, or form around piracy, marketing. It's literally what you read there is what we're bound by.
And there are other tools, frankly, the back-end registration database or activation database is going to have that information anyway.
Right? You just got to have the answer ready.
Yeah. Actually, we hope to do some very proactive things with the Richard Gibsons and Richard Smiths. That there's a couple of people who always come up when a privacy article comes up. What's his name? Steve Gibson and Richard Smith are the two guys who are always quoted in all the privacy articles. So there's a corporate privacy team under Richard Purcell at Microsoft. We've been working with them for the last year and a half. Have tried very hard to craft this user interface in a way that makes them happy, and they're fully sort of armed with understanding what goes on here. And we want to make sure that people just understand this for what it is and what it isn't, and are comfortable with that. We're doing sensitive things, and there's nothing wrong with that. It's just a question of how clearly we state that. Okay, one more. Yeah. Yeah. It's okay.
Is this the whole Office range, meaning front page and everything?
The question is this the whole Office range, meaning front page and everything? Yeah.
Business tools, Visio project, those guys?
Let me go back to the original slide. The net of it is, yeah, everything in Office, Office family. No, it's okay. I have the list at the very front, and it's just easier. There we go. So the net of it is literally all, yeah, there you go. All Office and Office family apps, Visio, etc. Visio guys were actually cool. They were in the company about 2 weeks, and they were knocking on our door going, hey, we heard you got this thing. They're terrific. And this is the set right now. A lot of this is in future beta versions coming up. My hope, honestly, is that over the next 2 years, everything we ship ultimately is going to be doing this kind of a thing, although this is who's getting either doing it or getting ready to do it today. Way in the back. The question was, because we know how do we how to reproduce. So that's an interesting question that cuts to the root of this. How do we know how to reproduce it? The amazing thing is we often don't know how to reproduce the problem, but we don't necessarily have to be able to fix the problem. It makes our testers happier when we can because they can really verify. But for a lot of these issues, you just have to sort of get the right 1 or 2 developers in the planet in front of the code, and they look around and they go, oh, wow, okay. We love it when we can actually determine how to reproduce this, and in the future we'd like to build more and more tools to make the debugging richer and richer. But today it's often just enough to know where you're blowing up and why. It's pretty neat thing. I mean, really, if you think about it, all we're doing is just putting a little bit of science around a problem that's been there all along and just letting all of our end users play in the game along with us. So.
Are there any plans to backport this to like Office 2000?
The question is, are there any plans to backport this to Office 2000? There are no current plans that I'm aware of. Simply that, it's collecting data is one thing. The thing is, Office 2000 is a fairly mature product. It's already past SP2. If our goal was to spend a huge amount of time delivering SP3 and SP4, then backporting this would make a lot of sense because this would drive quite a lot of that. But at the same time, I think that's a product that is at a certain point in its life cycle where we don't want a huge influx of data just about that. I can say that actually information we're getting, just people internally using Office, dogfooding on Whistler, because Whistler has the ability at a base level to send up information about any application. We're getting Office 2000 failures coming up, and we've actually already rolled fixes into some of the latest QFEs, amazingly enough. It's not like there's a brand new wave. We wish we'd had something like this in SR1 of Office 2000, but alas, we move forward. Yeah. The question is, what happens to mobile users when they're online? For V1, we track in their event log information about the bucket that they hit. In essence, app version, module version, offset. They can choose to escalate later. We haven't built a lot of machinery to be able to capture this offline in a local database and synchronize it later. Some pretty obvious things for us to consider doing in the future. The basic presumption is just that we believe that even just a small set of people hitting these issues is going to give us the true curve of what failures are going on, and that'll let us sort of get to the root of it. Again, for V1, it was just super simple. How quickly can we get this done? Offline was an interesting feature that we weren't able to do, but certainly would like to do in the future. But no promises.
The industry people that have commented on this feature so far, are their reviews mostly positive, negative?
The question is the industry people who've commented on this. Frankly, what people have noticed to date, more than the reporting, is the recovery stuff. It's manifests very clearly to an end user. I get to save my data. And in fact, that's really why we did that, because that's what's in it for the user today. During the beta cycle, we actually did a fun thing with Office 10 Beta 2, where a month after Beta 2 was out there, of course, when we deliver a beta, we're usually, by the time it really gets out to people, we're weeks ahead and already working on fresh code and fresh sets of problems. But we went and looked at the beta data, which was one of these very classic curves, and we took the fixes for the top 10 issues, and we rolled those up into a Beta 2 patch, and actually pushed that out via this mechanism and put it on the beta website, and got about a quarter of the users to download it. And the amazing thing was those 10 issues, just in Beta 2, accounted for something like 40% of the failures in the entire suite. So anyway, folks in the beta who sort of saw the full cycle of, hey, I crashed, but it saved all my data, cool, and then it turned around and said there's a fix, and then I installed the fix, and I suddenly started crashing a lot less, they were pretty jazzed. We'll see how this all plays out once we ship and sort of keep going inevitably. Someone's going to start noticing this someday, but that's okay. I mean, we don't mind just kind of working away. I mean, this is really all about just trying to make the software work. It's not meant to be really in your face. It's just accepting the reality that code does fail, and that's okay. We'll keep pushing forward. And so, what's really interesting is what it's starting to change in Redmond as our processes change. Literally, when we're in the very end games of trying to finish off Office XP right now, and a crashing bug comes up, often just because of this, like we didn't find it any other way, and we have data to make good decisions on, and it's really fairly incredible how it's changing how we do our work. I'm really excited to see what happens as we ship the product and sort of pass the baton off to the sustaining engineering team and see them start to really, really use this very aggressively. I'm super excited about the quality of what we're going to ship on day one, but I also know enough about the problem to know, hey, it's going to have defects as well, and those will manifest as a curve, and we'll just keep plugging away. Any more questions? Got to be close to out of time. Okay, well, I'll stick around for a few minutes. I really appreciate all your time, and I hope you sort of see what's going on here at the very early beginning of something pretty cool. Thank you.